Viewers, let's have a look at Ceasefire's kitchen suppression system, which is based on water mist. The Watermist system is the most environmentally friendly firefighting suppression system available from Ceasefire. Let us look at what is the problem with the kitchen suppression system. Whenever we need to protect a kitchen fire or a cooking oil fire, we are dealing with a cooking oil which is at very high temperatures in itself. That is about 330 degrees to 360 degrees and above. Fighting a fire like this with the water would be quite a challenge, because even if a single droplet of water enters the oil, it would expand instantaneously to 1600 times its volume, causing an eruption-like effect inside the oil, spreading the fire all around. Let us look at the Ceasefire solution on this. Here we have a water mist system where we have a supply unit, the container. Ceasefire offers three kinds of supply units: 11.5, 27 and 56 liter, which can be used individually or in combination. On the head of the cylinder, we have a valve connector, an indirect low pressure valve. On the head of the indirect low pressure valve, we have connected a HST, a heat sensing tube. And from the ILP valve, we have a line which can be either 15 NV or 20 NV depending on your system design, which enters a T, which is also called as a service T. The service T then goes on to a service ball valve. In case we need to empty the cylinder without discharging it from the nozzle, this ball valve is kept closed, your T is opened, and your system is discharged, and you can easily egress all the agent from here, which is just potable drinking water. Inside the cylinder, we have a very specialized unit or a dip tube, which is called a rotor. In 11.5 liter cylinder, we have a single rotor, and in 27 and 56 liter cylinders, we have 2 to 4 rotors depending on how many nozzles they have to operate. Now, what is a rotor? Rotor is a very specialized dip tube, as I said, which allows certain amount of the propellant agent from the cylinder to mix with the agent in itself, which is water here, and produce a bubble solution which will arise at a nozzle of a water mist system. When it arises at the water mist nozzle, then from the orifice you have pulses of randomly appearing propellant and water droplets which come into a collision course, and then they particularize into water mist. This effect allows us to produce very fine mist quality, which is very useful in firefighting of very high temperature fuel like cooking oil. Now we'll look at the extinguishing effect a little later. Let's look at some more components within the system. The output of this supply agent then goes through a supply line. It enters the fryer nozzles, and all the fryer nozzles are covered by the SS steel caps to protect them from any dust, grime or oil. The line then reduces while it goes from the fryer nozzles to the plenum area, and then in the plenum you have another nozzle, and beyond this nozzle again the line reduces, and then you have a nozzle which goes into the duct. Hence you can protect all the portions of your kitchen hood and duct. Now let us look at the working of this system. For detection and actuation, you have a heat sensing tube which is laid across the plenum. This HST is pressurized at 15 bars. The same HST is then also connected to the head of your ILP valve, and it is also connected to a mandatory installment of a multi-release block or a manual actuator. Now the system can react in two ways. One, where the heat sensing tube will rupture on reaction to any heat source. That releases any pressure within the HST. As the HST depressurizes, the pressure on the head of the indirect low pressure valve is removed. The pressurized propellant then pushes the agent out and in turn pushes the piston within the indirect low pressure valve and allows the content to now flow out from the output. Another way to do this is when somebody sees that there's a fire which has occurred and he wants to activate the system before automatic activation happens, and in that case you can remove the safety pin on the multi-release block, hit on the red knob, and this would create a puncture-like effect in the HST, releasing the pressure from the multi-release block. The system realizes this as an activation signal, and the same process which I had recently just explained happens, and the system discharges to release the agent through nozzles. Now let's talk a little more about the nozzles. All the piping, supply piping, cylinders and nozzles are made of SS. All the nozzles have their own protective cover to protect against any oil or grease. We have three kinds of nozzles which are available. One which is for the protection of the kitchen equipment. These are called circular single fluid heads of 08 type. Then for the plenum we use a circular single fluid head 10, which protects the plenum and the area behind the filters. And then for each of the ducts we have CSFH 11, which protects all the ducts. Now for the design of a system like this, it would be very simple. The designer will look at the spacing which is allowed within the fryer nozzles, which is going to be about 400 to 450 mm. With that spacing and the duct length, he can ascertain how many fryer nozzles he requires. Once he's calculated the number of fryer nozzles, he will then look at the plenum nozzle. The plenum nozzle would require at the most 1 or 2 CSFH 10 nozzle, and each of the ducts would require at least 1 CSFH 11 nozzles. Once we have calculated the number of nozzles, he will multiply all the assimilated nozzles in the fryer with 3 liters and plenum nozzle and duct nozzle with 2 liters. In this way, he can ascertain how much of agent or water he requires for extinguishment for a particular setup. Once the water is known, you can always go ahead and see which type of cylinder or what size of cylinder capacity you require for your variant as a fire suppression system. So for the purpose of this demonstration, what we're going to do is that we're going to heat up oil in a deep fryer. As this oil heats up, goes beyond 330 degrees centigrade, self-ignites, the flame will rise, the heat sensing tube will rupture, the system will activate, and the water mist will come and extinguish the fire. Now, speaking a little more about the water mist system, what's actually going to happen over here. As very small particles of water mist come close to the fire zone, what's going to happen is the large surface area which is created is going to start absorbing heat from the close vicinity of the oil or fire in itself, and without having to reaching out or penetrating the oil surface. This prevents the explosion type effect I had told you earlier in the video. So as the heat gets absorbed, the flame rapidly decreases due to lack of heat or reduction of heat. The flame goes down and eventually the fuel in itself also starts cooling, and this rapid reduction in heat brings down the temperature below the self-ignition temperature of the cooking oil. At the same time, we also have a response panel which can monitor system health of up to 4 suppression systems at one time. The health is monitored by a PGS, a pressure gauge switch, which can be connected into this response panel. The response panel has its own hooter, so it can monitor low pressure condition in the HST, and it can also give a hooter or alarm uh, at the time of activation. It has its own relay outputs, which can be used for third-party integration, like connected to a fire alarm system, connected to a BMS, or you can also have different kind of monitoring systems as you want. You can connect them over here, and if you want external hooter, that can also be connected. So all these possibilities are available from this response panel. Even if you want to connect a gas shut-off valve, okay, that can also happen through the response panel. In case we do not opt for a response panel, then in that case a different methodology has to be used to provide something called a gas shut-off valve or an electrical relay that supplies fuel or electricity to the hood, which needs to be cut down or needs to be shut down at the time of fire to see that the fire does not keep on heating up post extinguishment too. So this would be a very necessary step to have a monitoring panel like this, and by this connect a device which would shut down the gas or the electrical supply to the hood. So let's look at the demonstration of our Watermist system. Now, while we put in oil and we heat up, let us look at some more about the certifications that are available for this system. Now, Watermist system comes certified from LPS 1223. We've been selling this for quite a long time under this certification. The tube in itself is certified as per the requirements of LPS 1223, and it is also certified by UL 521 heat detection. All the cylinders would be certified by PED, Pressure Equipment Directive. And let's look at the demonstration now. Oil is heating up. We have not yet reached the self-ignition temperature, but we have fumes forming. As the fumes get denser, it will reach a stage where the fumes will catch fire and the vapor will carry the flames towards the HST, and the HST will then burst and actuate the system. The temperature right now is about 219 degrees centigrade. Now, if we were to look at the coverage of this kind of a system, then we can do cover hoods up to 8 meters in length and up to 10 meters with selective protection. Now, what is selective protection? Selective protection or zone protection is, in kitchen suppression terms, means when a group of equipment or a singular equipment is protected. That's called zonal protection. But when we are talking about total protection, then we are talking about everything under the hood. All the equipments under the hood are going to be protected. So we'll wait for a little more time for the fumes to thicken up and the oil to self-ignite. And once that happens, we'll wait for it to burst the HST and we'll see the suppression. The temperature has now reached 254 degrees centigrade and fumes are getting thicker. In just a little while, we're going to have a self-ignition on this. Now we have fire in our deep fryer. We will let the fire grow. As the fire grows and reaches higher up in the hood, it will rupture the HST and the HST will initiate a discharge. So we will step back at a safe distance. Our flames are rising. As soon as there is an activation, we'll hear a loud burst sound of the rupturing of the tube. Flames are quite high now. We should have the HST rupturing at any time. We'll hear a loud pop sound when this happens. Our flames are down. Our extinguishment is complete. There's no reignition. The oil surface looks quite calm. There doesn't seem to be any water droplets having any effect on it. Let's look at the temperature, which is now there. You can see the temperature has extremely dropped to 63 degrees centigrade now, which is quite low. So even if water droplets were to fall in, or we were to fill this oil with water also, it will never going to react with oil in terms of splashing out, because water requires at least 100-degree temperature. So here we have very low temperature, no thermal shock, very efficient extinguishment, no chemical effect, no toxicity, and you can see at the bottom there's very little mess around. Most of the water which was sprayed onto the fire evaporated and it's now gone. So that completes our demo for our Watermist KSS system, the Ceasefire and Viral.